Hello, my name is Leslie Perez, and today I will be presenting Plastic in California's Waterways, Short and Long-Term Effects. In California coastal regions, beach-going is a quintessential part of life. Beaches provide us food, recreation, entertainment, and a variety of environmental and economical services. According to the California Coastal Commission, marine debris is essentially any trash or litter that ends up in a marine environment or in the Great Lakes. It originates from a wide variety of locations and often travels great distances before ending up in the ocean. Marine debris can be found everywhere. It is predominant along every shoreline in the world. Pollution of oceans is an issue that can impact every country in the world and will be a persistent and devastating issue in future generations to come if it is not addressed immediately. Plastic harms wildlife by entangling them, harming their bodies through ingestion, and disrupting their habitat. As plastic photodegrades in the ocean, it releases potentially toxic substances not endemic to their ocean habitats, including ones that cause developmental defects in the species that live in these habitats. Debris from microplastics are often ingested by aquatic animals such as seabirds and fish. According to a research article published in Science Direct, over 690 marine species have been impacted by plastic debris, with small plastic particles being observed in the digestive tract of organisms from different trophic levels. The physical and chemical properties of microplastics can increase the absorption of pollutants and other contaminants to the surface of the microplastic debris, increasing the likelihood that organisms who consume these particles will suffer negative health impacts. Recently, a study conducted by the Aquatic Science Center showed that every year 7 trillion tiny pieces of plastic end up in the San Francisco Bay. The study measured microparticles and microplastics in stormwater from 12 small tributaries comprising 11% of the watershed drainage area to the San Francisco Bay. These tributaries covered a wide area where land use was designated as both urban and non-urban. The results showed that microparticles were identified in stormwater from all 12 study areas, with discharge rates between 1.3 and 30 microparticles per liter, reflecting exactly how pervasive an issue microplastics in waterways are in California. There are plenty of man-made sources of microplastics that are found in various everyday items in households, including body and face washes, exfoliating scrubs, and cleaning agents. In an article published in Science Direct, the researchers discussed the presence of microplastics in personal care items such as cosmetics and cleaning agents. According to the article, the mass emission of global PCP-derived microplastics reached up to 12,000 tons per year. In the last 50 years, between 1970 and 2019, up to 300,000 tons of PCP-derived microplastics have accumulated in the environment. Microplastics in cosmetics and cleaning agents is such a concern that in 2015, the Microbead Waters Act of 2015 was passed, effectively banning the manufacturing, packaging, and distribution of cosmetics containing plastic microbeads. This act was passed in an effort to prevent the spread of microplastics in the water supply. However, microplastics can persist in the environment for a very long time. There is research into various solutions for problems concerning plastic accumulation in the natural environment. Recently, a new enzyme was discovered that has the ability to consume plastic. This enzyme can digest highly crystalline PET, which is the primary material used in single-use plastic beverage bottles, in some clothing, and in carpets. It can grow on PET and utilize it as a carbon and energy source. Ideonella sacchariniensis secretes PETase, PETase, which is a PET digesting enzyme. Because plastics are accumulating so quickly in our environment, it is being discovered that microbes are adapting and evolving enzymes that are capable of degrading man-made plastics that are increasing in amount. However, there is still some question as to whether these enzymes can be used for the large-scale issue with plastics, and research is still ongoing. A separate research team found that waxworms, also called Indian meal moths, were capable of chewing and eating polyethylene. In an article published by ACS Publications, researchers found that there are two bacterial strains capable of degrading PE were isolated from the worm's gut. Over a 20-day incubation period of the two strains of on PE films, viable biofilms formed and the PE film's hydrophobicity decreased. Obvious damage, including pits and cavities, were observed on the surfaces of the PE films using scanning electron microscopy and atomic force microscopy. The results of the study demonstrated the usefulness of the PE degrading bacteria in the guts of waxworms and offered promise for future research into the digestive capabilities of organisms and plastic. There are many issues that are associated with societal dependence on plastic consumption, including unintentional consumption of plastics by organisms through the trophic levels, plastic accumulation in California's water supplies, and the degradation of our already strained and fragile ecosystem. However, there are many solutions that are being researched, including studies of microorganisms that have evolutionarily adapted to use plastic as a source of energy. Plastic waste impacts every facet of the environment, but there are incredible efforts to minimize and alleviate the damage. Thank you for your time, and I hope that you've enjoyed my presentation.